you.
Good. So what do we got
Okay.
tonight?
I sent you a picture. It's just my quiz review. I have a quiz on Friday.
Okay. Let me get these side by side here.
Mm-hmm.
Every now and then that doesn't work. Do you have Windows 10?
I have 7.
Okay. Usually when I do it a second time it works. Alright, let's expand that a little bit. Where would you like to begin?
I just kind of want to go through it all and make sure I know how to do everything.
Okay, let's start with the first one.
Okay.
If I can figure out how to get that picture out of the way, maybe I can do. Let's see, it's the limit of f of x as we approach 1 from the left.
Mm-hmm.
What's that limit?
Would that be 1?
As we approach 1. In other words, as x approaches 1.
Oh, okay, so 0.
Correct. In other words, there's the function. We're going to follow that function until we almost get to 1 on the x-axis.
Okay.
That limit is 0. And 2 says from the right, I presume?
Yeah.
What does that
So, would that be 1?
Correct.
Yeah.
So what's the limit at 1?
It doesn't exist.
Okay. What is f of 1?
Would that be 1?
Correct. That's that point right there.
Okay.
And it's there rather than there only because it's a closed dot versus the open dot.
Right.
What's the limit as we approach 2? What is that, from the left or the right?
Mm-hmm. The left.
Okay. What is that limit?
Would that be 1?
Correct.
That would be 2.
No.
Or 1, okay.
In other words, always get on your function and just start drawing arrows and get closer and closer to the x value. And it's where those arrows are pointing, which is your limit.
Okay.
Okay? So the limit as we approach 2 from the left is 1. What is it as we approach 2 from the right? Even though it doesn't have that on there, it's still an important observation.
Would that still be 1?
Correct.
Okay.
So what is the limit at 2?
1.
Correct. That's what's hard for a lot of people to accept.
Yeah.
That even though f of 2 is equal to what is f of 2 equal to?
F of 2, that would be 2.
Correct. Only at that point right there. Even though that limit points to 1 and that limit points to 1 and the limit at x equal 2 is 1. Because from the left it's 1 and from the right it's 1, regardless of whether f of 2 is not that same value.
Okay.
What's the limit as we approach 3?
That would be 2.
Okay. Find the limit algebraically. Okay. How are we going to do that on the first one?
So that's just -8 over 0, so that would be 0, so you have to do,
No, hold on. It would be 0 over 0. In other words, when I substitute 0 for x, I get 2 cubed, which is 8, minus 8.
Oh, yeah. Okay.
So it's a 0 over 0. I can tell you right now, every one of these is going to be 0 over 0.
Yeah.
Because otherwise they wouldn't be giving them to you.
Okay.
Anything that's not 0 over 0 is easy.
Okay.
Okay? So what we have to do is expand that and then see if it simplifies.
Okay.
And I know that it is because you know after I cube that binomial, I'm going to have a plus 8 on the end, right?
Right.
And that 8's going to cancel out with that 8 right there. And
Mhm.
everything else is going to have an x in it.
Okay.
And then I can factor that x out, get rid of the x in the bottom, and then evaluate what's left. So let's start by multiplying it once.
Okay.
What is that term?
X squared plus 2x will be 4x.
Plus 4x. You know, this is not a bad thing to memorize. In other words, a plus b squared. Memorize that because you have to do it so often. It's
Mhm.
b squared plus 2ab plus b squared. And in
Okay.
our situation, a is x and b is 2. So it allows you, without going through the foiling process, because when you go through
Mhm.
the foiling process, you end up with 2 terms in the middle that you then have to simplify and
Right.
combine. Well, if you go this way, you don't do that. You just get directly there.
Okay.
Okay? Now we want to multiply that by that. And I could write it either one, but you and I haven't had much practice multiplying trinomials by binomials.
Right.
So what is that going to be?
So x to the third plus 4x squared plus 4x. And then 2x squared.
It's a nice way to do this. Notice that I shifted vertically,
Mhm.
and I had room over there, and I was going to write, but I didn't have enough room to do the whole thing. But when you shift it vertically, you can line things up,
Mhm.
which is helpful.
Okay.
The rest of it.
Plus 8x and then plus 8.
Now it's easy to simplify that.
Yeah.
And I still have to subtract that other 8, right?
Right.
So that's my function. Well, that cancels with that. And now what?
Okay.
In other words, if we substitute it, we're still going to get 0 over 0.
Yeah.
But I can simplify this.
Okay.
How do you simplify it?
Do you take out a greatest common factor?
Basically, yeah, and that's x. In other
Okay.
words, I'm going to factor an x out from these 3 terms because that's all I have left in the numerator, are
Right.
those 3 terms. And the thing is, I want to factor an x out because I want to get rid of that x that's in the denominator. That's what's causing all the problems.
Yeah.
So that's my new numerator. Here's my denominator. Now I can evaluate that as x goes to 0 and it doesn't end up being 0 over 0.
Okay.
What does it become?
That's just 12.
Right. And that is the limit.
Okay.
Okay. So all of these are going to be the same strategy. Well, maybe not all of them. I shouldn't say that until I look at them. But mostly it's going to be factoring or using what you know to be true, like sine squared x over x. We don't know what that is, but we know what sine x over x is.
Okay.
Okay. Let's do 10 real quick. Go ahead and factor the numerator.
All right. So,
And I don't even have to test it to know it's going to be 0 over 0. So
Yeah.
just go ahead and plow into step 2.
Okay. So the numerator,
best way to factor is with 3 or 4 simple steps. Always do them in the same order.
okay.
Don't try to take that quadratic and figure out what the factors are all in one step, which is what it feels like you're doing.
Okay. So
Step 1, split the x's up.
mhm.
Step 2, determine both signs. What do
Okay.
the signs have to be?
Negative and positive.
Right, they have to be opposite.
Yeah.
Doesn't matter whether I do it that way or the way you said it. And now the third step is what?
What multiplies 21 and what adds to 4?
Not adds but subtracts because of that negative sign in front of the 21.
Oh, okay.
So I want factors of 21 that subtract to 4. Well, what are those?
Wouldn't it be plus 3 and then minus 7?
Yeah, it's 7 and 3.
Yeah.
That's step 3. And then you put the larger of those factors with the sign of the middle term. Well, the middle term has a negative sign, so I got to put the 7 there and the 3 there. That's the way I factor stuff every single time. I don't try to, if you're good enough to do it all in one step, that's fine, but I'm not. How does the bottom factor?
That's just x minus 3 and then x plus 3.
Now what can I do?
You can get rid of the x plus 3's.
And now almost certainly when we substitute minus 3, we're not going to have 0 over 0. What do we get?
So negative 3 minus 7 over negative 3 minus 3, which is negative 10 over negative 6.
Keep going.
That would be positive, right?
Huh?
So just 10/6.
5/3.
Oh, okay. Oh, because you're okay.
Always simplify. Not,
Okay.
you'd probably lose points if you gave that as an answer.
Yeah.
You'd lose at least 1.
Mhm.
Okay. 8 sine squared x. I'm going to write that this way. Basically factoring the sine squared x.
Okay.
And I want the limit as x goes to 0. Well, I know what the limit of sine x over x is as x goes to 0. What's that limit?
That's 1.
So I got 8 times 1. What does this sine x do as x goes to 0?
That's just 0.
Correct. So I have 8 times 1 times 0. That limit is 0.
Okay.
Sine x minus 4x over x. How should we do this one?
So sine x over x is 1, and then negative 4x over x is just negative 4.
Yeah, basically what we want to do is split this into 2 fractions.
Yeah.
In other words, it's easier to think about if we do this. And I can always do this. In other words, as long as my denominator is a monomial term, I can split this up into 2 fractions. And now those x's cancel. And you're right, there's my 1 minus 4, so the limit is minus 3.
Okay.
Was that 12?
Yeah, so we're on 13.
Ooh. Maybe they're not all 0 over 0. Since we don't have a denominator here, they must not be.
So is that just substitution?
Uh-huh.
Okay.
So what is it?
So 2 squared is 4 times 3 is 12. That's minus 8. So 4 plus 2, so 6.
Yeah. Okay.
Perfect.
The next one is not 0 over 0 either. In other words, at the very minimum, the numerator is 6. So my assumption was false. Do you even want to do these?
No, that's okay.
Yeah, let's skip those. I mean, as long as you realize that if it's 6 over 0, which is not, because the bottom is always positive also, it's 9 plus 1. So, but if it was a number over 0, that's infinity.
Okay.
If it's 0 over a number, that's 0.
Okay.
The greatest integer function, the best way to figure this out is by graphing it.
Okay.
That's probably enough, although there is another key point on the left of the axis.
Mm-hmm.
So what's the limit as we go to negative 1/2? It is right here. This is negative 1. This is positive 1 up there. And this is positive 1 here.
Okay. Would that be negative 1?
Yes.
Okay.
All you need to do is get on the graph and head towards that minus 1/2, and where do you find yourself? At negative 1.
Okay.
And it's important to understand that it's the horizontal axis that we're always approaching, and it's the vertical axis that our limit is found.
Okay. So how would you prove that algebraically?
Good question. Not sure. Not sure.
There's not really any way.
Well, notice that all the others we substituted. I guess substitution. In other words, we didn't do 13 by algebra either. We just substituted. Came up with a number. So let's substitute. We got the limit of the greatest integer function of negative 1/2.
Yeah.
And it's important to understand that with the greatest integer function, if you're to the right of 0, then you drop. In other words, if I want the greatest integer of 1/2, I just drop the fraction. It's 1. But when I'm, so let's see, I came up with a system once here. So I'm always moving to the left.
Okay.
Well, if I'm at negative 1/2, I have to find the integer that's to the left of negative 1/2.
Okay.
That's minus 1. So I don't know that that helps. It's not really algebraic, but that's actually not a bad thing to know.
Yeah.
And because it is different whether you're to the right of the y-axis or the left. In other words, the greatest integer of 1/2 would be 0. So it's not at all obvious that the greatest integer of negative 1/2 would not be 0, but it is. It's negative 1. It's not 0. And the way to really think about it is if you're looking at a number line, whatever number they give you, find the integer immediately on its left, and that's the answer.
Okay.
I don't know how else to explain that algebraically, to be honest.
Yeah, no, that makes sense.
That should be good enough, I think. So back to the numerator.
Okay, so negative 3 and 2 and then the x minus 3's would cancel, and then it would just be 3 plus 2, which is 5.
Okay. We're going to run out of time before we run out of problems. Let me be a little selective here.
Yeah.
I want you to, let's look at 19.
Yeah.
For sure. Because it's not obvious how to do 19.
No.
But once I tell you, you'll think it was obvious.
Okay.
I multiply top and bottom by 4. There's the top by 4. There's the bottom by 4.
Okay.
Now, what's the limit of that as x goes to 0?
The 4x's would cancel, so it's just 4 sine?
No, the 4x's don't really cancel. We know that the limit of sine of x over x is 1.
Oh.
So this
So it
is
would
going
just
to be
be 1 times 4?
Yeah. In other words,
okay.
No matter what the argument is, if you're dividing by that same argument, then you basically have this.
Okay.
I could use u substitution if you like. Let's let u equal 4x. Well, then we have the sine of u over u all times 4. Well, I know what that is. That's 1. No matter whether I'm calling it u or x. But that's what you're looking for, is for that to be the same as that, no matter how complicated it is. It could be super complicated. It could be some super complicated rational quotient. As long as the denominator is the same, you're fine. Number 18. Let's go backwards.
Okay.
What's the first step going to be?
Would you take out greatest common factor?
Okay. So what's the numerator look like?
So that's x squared, and then times 2x squared plus 3. And then the bottom would be 2x squared. And then 2x to the 4th minus 3.
Now notice that it wasn't particularly helpful to take out that 2.
Yeah.
In fact, I'm better off if I leave it in. And I'll show you why. Because I'm going to have to redistribute it. After I cancel those two, now I got to multiply that 2 back together. Well, I guess I don't really. I can take the limit of that. But it wasn't actually helpful.
Okay.
So when you see that, don't worry about factoring out the greatest common factor. Worry about getting rid of the x squared that's now in the numerator.
Okay.
All I need to do is factor out an x squared. Well, now when I plug in 0 for x, I get 3 there and minus 6 here. So that limit is minus 1/2.
Okay.
Okay. The goal is to always get it away from 0 over 0.
Okay.
17. We could do that the way we did the one earlier that was cubed.
Yeah.
But there's a rather clever way to do this. It's a little different.
Okay.
Notice the numerator is the difference of perfect squares.
Yes.
So if I look at the numerator as the difference of perfect squares, how does it factor?
That would just be x squared plus 9.
Well, a is 3 plus x.
Okay.
Minus 3. There's the a minus b. You see that?
Yeah.
What's a plus b?
Just x plus 3?
Yeah.
Oh, okay.
It's 3 plus x plus 3. In other words, I'm treating a as this quantity right here.
Okay.
So I have a squared minus b squared. B is 3.
Mhm.
So I can more easily, if I see it, use difference of perfect squares, and then I bet you all these 3's are going to go away. Well, hold on a moment. Yeah, those two 3's go away. So now I have x times x plus 6.
Yeah.
That's helpful since I'm dividing by an x. So now I can substitute x going to 0 and I get 6.
Okay.
Not sure I necessarily saved a step. In other words, it would have been just as easy to multiply that out, especially since I only have to square it.
Mhm.
But if that was cubed, I can use difference of perfect cubes if it was appropriate. It wouldn't be if that's a 9, but if that was an 8, I could have used difference of perfect cubes on problem number 9.
Right.
Because my a cubed, a would be x plus 2, and my b would be 2. So it is
Okay.
difference of perfect cubes, and I could have factored it similar to this. And I was going to mention that, but I'm not sure that it's actually any easier.
Okay.
But it is nice to observe that you could use difference of perfect cubes up there or difference of squares on 17.
Okay.
Okay. 20 is going to be very straightforward. You're going to factor
Mhm.
the numerator. You're going to factor the denominator. There is a factor in common. You're going to cancel it,
Yeah.
reevaluate it. 21. We're going to factor out in what from top and bottom?
X squared.
Yeah, and that's going to take care of the problem.
Yeah.
Because the new bottom will have an x minus 2 that doesn't go
Right.
to 0 when x goes to 0. 22 looks interesting.
Yeah, I was gonna ask.
Yeah, let's do 22 with our remaining 3 minutes. Now, you cannot split that into 2 fractions.
Right.
But what can I do? In other words,
Um.
that's not sine x over 3x squared plus sine x over 4x.
Right.
If there's a binomial term in the denominator, you can't split it up. But I can do what?
Take out a common factor in the bottom.
Yeah, which is
And that just be x.
leaving,
3x plus 4.
and I know what that is. That's 1.
Oh, okay.
So I end up with 1 over, this is being done as x goes to 0, so I end up with 4 in the denominator. Now,
Okay.
real quickly, let's do 23 because we haven't done a problem like 23 before. And it
Yeah.
requires a little, it's not a factoring problem.
Okay.
It's a subtract that fraction from that fraction problem.
Okay.
So how do I do that?
So it would just be,
And
well,
notice
I'm not
direct
sure.
substitution does result in 0 over 0.
Yeah, right.
Okay. Well, calculus requires some fairly sophisticated algebra.
Mhm.
And you need to find a common denominator. So what's the common denominator going to be?
3 minus x.
No? It's
No?
always the product. When you have something like this. Now,
Oh.
if I had 1 over x minus 1 over y, the common denominator is x times y.
Okay.
Okay? Well, my common denominator here is the product of these things, which is this. What's my numerator here and here? And I'm still completely in my numerator here. In other words, that's what I'm looking at.
Okay.
What has to be here such that this fraction is exactly the same as that fraction?
Okay. Would it be 3?
Yeah.
Okay.
What has to be here such that this fraction is exactly the same as that fraction?
3x.
3 minus x.
Oh, okay.
See how it hasn't changed?
Yeah.
But there's a extreme danger here in that it requires us to put parentheses around it. If I don't put the
Okay.
parentheses, I'm getting the wrong answer.
Okay.
Okay? And here's why. When I combine my two numerators now, I now have a common denominator. So there's my denominator.
Mhm.
But with the parentheses, the answer is plus x.
Okay.
Without the parentheses, it's going to be minus x.
Okay.
So having to add those parentheses is critical.
Okay.
Now, flip the bottom, put a 1 under the bottom if you don't see it, and then flip and multiply, and it gets rid of the x. So those cancel, and I end up with a 1 right there. And
Okay.
that is our result after all of the algebra. And now when you plug in x going to 0, you get 1/9.
Okay.
Okay? So the way you come up with that number right there is you divide that into your common denominator, take the answer,
Mhm.
multiply it by that numerator.
Okay.
When I divided 3 into my common denominator, I got 3 minus x is the answer. Multiplied it by
Mhm.
1, that's what I wrote right there. And
Okay.
now in checking, always check. Always be checking. It's a great rule for math. Always be checking, making sure that you did not change the fraction from here to there.
Right.
Okay? Emma, I'm going to have to run. I'm 2 minutes late for my 7 o'clock.
Okay, thank you.
You're welcome. I'll talk to you next time.
Sounds good.
Bye-bye.
Bye.